Hello, I'm working since longer with Braumat system of Siemens, and I want to communicate how easy it is to work with Braumat and to generate fast solutions for breweries and many more. Enjoy. Thank you. Okay, it's recording now. So to make the engineering, we have one tool based on Excel to speed up the generating of the program. Yeah, I opened the file already. It's called template. I can show you on the hard disk. Template EOP English version 7, version 6, and also for SM7 1500. So this tool can generate the STL code and the SCL code. Yeah, SCL, SCL. What you have to do to use this tool? The beginning is, I think you have done this already, to think about the units. Yeah, which units you're using. That means, for example, one tank is one unit, one CCT is one unit. The Lauter ton, the mesh ton, the wild kettle, the whirlpool, all these are units, and for each unit you have this Excel. Yeah, you have a template, and then you make copy to all the units you need. Yeah. Let's suppose you have this structure already. You have made these units already, and then you need to fill this template with content, with your elements, and you do this in the reference. In reference, in the beginning here, you write down which ICM is in this unit, which ICM you're using in this unit. For example, this one is a Lauter ton or whatever. Here this V11, V12, V13, V14, and so on. Yeah, all the elements, including the name. Okay? Okay. Yeah. What you see in this matrix, that it's coming up here automatic. All what you're writing in the first one, it's coming in the next tab. In these columns, yeah? This is the same like this one. So if you make, this is not V12A, you see, although this one changed, the name changed. But you have not only ICM, you also have digital inputs. That means full signal, empty signal, yeah, flow switch, and so on. And these signals, which are relevant for this unit, which you are using in this unit, only this one, you put in here. So this information you get from the client, or you get from the existing project. From the symbolic file and yeah, maybe you see it in the screen. You can see the name, the tag name of the elements, and you can put this all together in this Excel. Some more information is the DFMs. As far when you know a little bit Braumat, and I think you know Braumat, you need the DFMs for the next step condition, for the time, for the decoder, and so on. And in these columns here, the DFMs for the transition should be implemented, should be put, including a command. Okay? If you need some more flags later on, feel free to put it here. Yeah, some flags for interface signal and so on. This can be done in here. That at the end, all the elements and flags is for this unit is in this Excel file. Altogether is in this Excel file. That's a goal. All this information is going to matrix, and the matrix is a FDS which is used by many companies. Many companies like Filtrox, they are using this way for description of the process. I think it's quite clever, yeah, to write in here in the first column the name of the steps. Start position, yeah, for example here you write start position, start Lauterton. Yeah? And this name you get from PC7. This name you can get from the other project. The name of the different steps. You have to investigate, or you give it to the client and he should tell you, first I fill my vessel, then I'm heating up, then I'm cooking, and then I'm flushing. Yeah? This is the technology. Yeah? And normally you find these names in the FDS.
Yes.
Yeah? And now, what the client can do, or what you can do, you can say, in the first step, I open this valve to get the rest to the drain, for example. You make an asterisk in here, it's a little bit small, but here, I don't know, there's a drain or somewhere. You open the beginning, in the first step, you open this valve. You make an asterisk. That means all the time when the step is running, this valve is open. And this is very easy. The client can do it by himself to give you information how this should work. And you continue. The same, the second step in meshing in, the inlet valve is open. And that's it. And maybe the pump. Heating up, for heating up, the steam valve is on. And the steam valve is in here. The steam valve should be activated. And agitator. Okay, you can follow? Very good.
Yeah.
And rest means making coffee break? No, it means waiting, including heating for a certain time. Rest means to make not really a break. That means the steam valve is still on and the agitator is running for a specific time. For a specific time. And the time, it's on the right side. Later on I go to the transition. The time you will find here on the right side. Here are the transitions. But let's go one by one. Yeah? In this case we are now in rest. That means here the transition is a time. Yeah? And for you, and for this one you are using a DFM.
Yes.
And the DFM you find in here, DFM 1.10. Yeah? So we can copy, paste this one to here, DFM 1.10, and you can say if it's more, you make it bigger. That means if the time is finished, go to the next step. The transition. In this step we have something, let's say new. Here you have this set point temperature. You see set point temperature mesh, and this, for example, should be supplied with the temperature, with the value, let's say 62 degrees. 62 degrees. You can write the set point in here that you have all together in one sheet. That's the goal, to have all together in one sheet. And the next one, heating up, it's going to 66 degrees, and then in the rest time it remains at 66 degrees. Okay, that's the technology. Yeah, that's the technology. Now there is something. In reality, you want to have the steam valve switched off when the temperature is okay. Yeah, sorry. In the step before, the next step condition is a temperature. Temperature, okay? And the temperature means more than, and you see the temperature in here, 1.11. DFM 1.11. Okay. The temperature. In this rest time, you should switch off the steam valve when the temperature 66 degrees is okay. Otherwise the temperature is going too much up. And how you're doing this one? In this way, you have to see this number in here. It's 140. It's a bit small, but in this I see the column 114. That means the valve is switched on conditionally depending from this DFN.
Yes.
Yeah? I go in here. (114). Instead of making asterisk, you make a 114. But it's not really 114. There is a description here. When you are using this Excel, you have some information. He say 1000 means to check with and not. And not. It means you make 1,133. I write the correct one. The correct one is 1000. 1. That means when the temperature is below 66 degrees, it's on and not. When it's above 66 degrees, the valve is switched off. If complicated, I show you again. It's a special function now of this Excel, which is described in here. You make something with 1000 plus a number, and then the following number is the column for the interlock. And if you write 2000 plus a number, it's a column plus and. At the end, you say and. The first one is and not. 1000 and 2000 is and not. So in this case, you can make conditionally switch something on and off, in this case, depending on the temperature. Okay. We can have it for heating hub as well. And this 114 copy paste here in the rest as well. That we are not going above the temperature. We make sure if there is something trouble or that the steam valve is not on too long time. Okay. Receive partial mesh. Receive partial mesh. In this case now we are getting some more mesh from another vessel, from the mesh ton 2. Yeah. In this case, we have the pump is on. The pump to fill. And the inlet valve. Unconditionally. And now you need a signal to tell to the second vessel that you want the mesh, that you want the mesh is the water and the malt, the mesh. Yeah, and for this one you need a flag now. If you don't understand, you could look the video and then you understand. Okay, in here we write now a flag 1.0. In this case we reserved already some flags and we say receive mesh okay. Okay? Receive the mesh is okay. I'm okay to get the mesh. Yeah? And this flag must be activated now. We go on the matrix to the right side. Here we are. And in this we need, there is a comment. You see this red. If you make asterisk, then it's on. Yeah. And then you can have it conditionally on depending from the coder and so on. There are some more functions. In our case, we only switch this one on. We switch this signal on. Okay, in this step I send the signal to another unit. Please, I want mesh. And the other unit is giving a signal back which we need to define, which is called mesh is okay. The mesh is okay. I'm sending you the mesh. This is a communication signal. And for this one, you go here, the next flag, mesh from MTK. No. Come on. Okay. 1.1 mesh from MTK, okay. And this is a transition condition. When this flag is coming back, we know, okay, we go on the next step and make the transfer. Okay, receive mesh okay, but let's say as long as we don't have this signal, we are not running the pump. We are waiting for the signal. When the signal is coming, the pump should be switched on. So you remember, maybe we go now on top here, 11107. Okay? 107 is a column, and you go to the left. 107. Okay. Sorry. Ja, hallo Stefan. Ja, Jürgen, im Moment ist ganz schlecht. Ja, ruf bitte. Ja, so eine 2 Stunden. Ja, 2 Stunden, ja, genau. Ja, okay. Alles klar. Ja, ciao. 107.
Thì cứ nghe đi rồi cái gì sau thảo luận nữa.
107. And the same, I make this 11107. 1107. That means I check and the signal must be on. That means 2000 in here. Okay?
That means the you start when you receive the signal from the 107.
Yes, when the signal from this column 107 is on in here. Oh, it's not the name is not yet here. I need to write it the name. I need to write it here. Yeah, because it is MDK. Okay. Let's say it's any flag. It could be any flag. We write it on the right side, and here makes a symbolic. Now let's do it the other way around. 0.3, and here the mesh. You're right. It should be here because it's and not here. So now we see the name is coming here. Mesh from MTK is okay, and the flag is M33.3. It's any flag, and then this flag is 1. Then I switch on the pump and the inlet valve. And when it's 0, it stops. Okay? Maybe you question why you're doing this. What is this? Yeah, it's because from this one, I want to show it to you right now. You can generate the code for Braumat automatic. If you go to macro. generate code, because in this Excel there's a macro, and you say execute, you have directly the code. You don't need a program. From this Excel is generating the Braumat code as a source. That means as a text file. Yeah. And when we are going down here now, you see now there is a header, the EOP number. The EOP number is coming from here. That means this column needs to be filled by you. You need to say which EOP I'm using for this unit. In this case it's 31, 32, 33 and so on. You make a table and then you write down here the EOP, because this is coming here in the header, which EOP is used. It's generated. Then you can write your nice name in here, or from your girlfriend. It's up to you. You see there is a header, the comment of the network, and not flag 102.3 makes the agitator switched on in the first step. The next step is the transition. This one is for the release of the time. For the time you need to release a flag, the enable flag. This is the next one. And the third network is the transition, the condition for the transition. So this is for the first step. Let's go to the second one, FC 1032. You see V111A command. That means this is a signal which need to be the same in the symbolic file. Needs to be the same in the symbolic file. Yeah. How you can ensure that? Sorry, I forgot this one. You can ensure that by going macro setup to give this all these basic settings of this Excel file in here. In this Excel file you write in here, the extension is CA, for example, command automatic. Normally it's CA. And this is not Stefan Stronger, it's Tien. Okay, your name is Tien? I don't know. But I name you Tien. Because I had a girlfriend which was named Tien. Okay, Tien, and so on. You can write here, which is on the header, so you don't need to write in each step this name and all the things again. It's generated automatic. And the DFM extension, for the DFM, also you need to write this one. Let's say it's called result. But this has to be compatible to your semantic manager symbolic file. Has to be the same. And when when I generate this template again, it's also called Alt F8. Alt F8, then it's coming. Then you see it changed now. Now it's called MCA, command automatic, for the signal. Here, Tien, your name is coming up, or your girlfriend's name. Yeah. and so on. And here you also see the transitions now. Let's go a little bit more down. Transition. The DFM 111 result, the temperature. In this line, what you input in here on the right side, it's coming up. So you have 3 conditions. Here you can generate an operator request. If you make O, sorry. Here is the and or the condition and. You have several transitions, whether you want it and or. Yeah, you can say and temperature and time. Let's say temperature. Or you say or. If one of these conditions is okay, then go to the next step. So in this column, you define whether it's an and condition for the transition or an or condition. Here, this on the right side is concerning the conditions, the next step conditions, the transitions, and this one is the digital conditions in this column, and in this one is the, let's say, the DFMs. The DFMs you do have, and you can write down here what is really the next step condition, the transition condition. You see there is something with root control. If you have a root control, you can also activate the according code. Okay?
Any
Root
version?
control.
How if this student I have more than 1, 2, 3, 4, around 10 DFM, if I have more than 10 DFM here,
Yeah, if you have, okay, you can set it up in here. In this macro setup, you can design this Excel file. You can say you have 22 DFMs or you have 128 ICM. You can say the columns for output going from here, the columns for operator requests is in here, red PID. So this matrix is a little bit flexible. It's a little bit flexible. You can make more. Yeah?
okay.
Yeah, you see DFM set point scale from 113 to 122. And in this case you say to 125. But then for sure you have to change all what is coming after that. You also have to change the numbers. Yeah. As you know, this is based on Visual Basic. The code generator is a Visual Basic and you can change it. So you can go in the code, it's open source. You see the code in here and so you can modify it. If you don't understand something, you can take a look in here, how is it going, and you can change and also input new code to the Visual Basic in here, and then you have it. So it's a proposal, but you're free to change it, you adapt it to your requirements. You're free about that. Okay?
Okay. But now I have only FPS in test file, and with your experience,